Earth is the third planet from the Sun and the only astronomical object known to harbor life. While large volumes of water can be found throughout the solar system, only Earth sustains liquid surface water. About 71% of Earth's surface is made up of the ocean, dwarfing Earth's polar ice, lakes, and rivers. The remaining 29% of Earth's surface is land, consisting of continents and islands. Earth's surface layer is formed of several slowly moving tectonic plates, interacting to produce mountain ranges, volcanoes, and earthquakes. Earth's liquid outer core generates the magnetic field that shapes Earth's magnetosphere, deflecting destructive solar winds. Earth's atmosphere consists mostly of nitrogen and oxygen. Greenhouse gases in the atmosphere like carbon dioxide, CO2, trap a part of the energy from the Sun close to the surface. Water vapor is widely present in the atmosphere and forms clouds that cover most of the planet. More solar energy is received by tropical regions than polar regions and is redistributed by atmospheric and ocean circulation. A region's climate is governed by latitude, but also by elevation and proximity to moderating oceans. In most areas severe weather, such as tropical cyclones, thunderstorms, and heat waves, occurs and greatly impacts life. Earth is an ellipsoid with a circumference of about 40,000 kilometers. It is the densest planet in the solar system. Of the 4 rocky planets, it is the largest and most massive. Earth is about 8 light-minutes away from the Sun and orbits it, taking a year, about 365.25 days, to complete one revolution. Earth rotates around its own axis in slightly less than a day, in about 23 hours and 56 minutes. Earth's axis of rotation is tilted with respect to the perpendicular to its orbital plane around the Sun, producing seasons. Earth is orbited by one permanent natural satellite, the Moon, which orbits Earth at 380,000 kilometers, 1.3 light seconds, and is roughly a quarter as wide as Earth. The Moon always faces the Earth with the same side through tidal locking and causes tides, stabilizes Earth's axis, and gradually slows its rotation. Earth, like most other solar system bodies, formed 4.5 billion years ago from gas of the early solar system. During the first billion years of Earth's history the ocean formed and then life developed within it. Life spread globally and began to affect Earth's atmosphere and surface, leading to Earth's great oxidation event 2 billion years ago. Humans emerged 300,000 years ago, and have reached a population of almost 8 billion today. Humans depend on Earth's biosphere and natural resources for their survival, but have increasingly impacted Earth's environment. Today, humanity's impact on Earth's climate, soils, waters, and ecosystems is unsustainable, threatening people's lives and causing widespread extinction of other life. Etymology. The modern English word earth developed, via Middle English, from an Old English noun most often spelled eor. It has cognates in every Germanic language, and their ancestral root has been reconstructed as *ar. In its earliest attestation, the word eor was already being used to translate the many senses of Latin terra and Greek gamma ge, the ground, its soil, dry land, the human world, the surface of the world, including the sea, and the globe itself. As with Roman terra/tellus and Greek Gaia, Earth may have been a personified goddess in Germanic paganism. Late Norse mythology included Earth, a giantess often given as the mother of Thor. Historically, Earth has been written in lowercase. From early Middle English, its definite sense as the globe was expressed as the earth. By the era of early modern English, capitalization of nouns began to prevail, and the earth was also written the earth, particularly when referenced along with other heavenly bodies. More recently, the name is sometimes simply given as Earth, by analogy with the names of the other planets, though Earth and forms with the remain common. House styles now vary. Oxford spelling recognizes the lowercase form as the most common, with the capitalized form an acceptable variant. Another convention capitalizes Earth when appearing as a name, for example, Earth's atmosphere, but writes it in lowercase when preceded by the, for example, the atmosphere of the Earth. It almost always appears in lowercase in colloquial expressions such as, "What on earth are you doing?" Occasionally, the name Terra/Tr/ is used in scientific writing and especially in science fiction to distinguish humanity's inhabited planet from others, while in poetry Tellus/Tls/ has been used to denote personification of the Earth. Terra is also the name of the planet in some Romance languages that evolved from Latin, like Italian and Portuguese, while in other Romance languages the word gave rise to names with slightly altered spellings, like the Spanish tierra and the French terra. The Latinate form Gaia or Gia, English/die. Of the Greek poetic name Gaia, Gamma Alpha Alpha, Ancient Greek, Gai.a, or Gai.ja, is rare, though the alternative spelling Gaia has become common due to the Gaia hypothesis, in which case its pronunciation is /Gai. Rather than the more classical English /Gay. There are a number of adjectives for the planet Earth. From Earth itself comes earthly. From the Latin terra comes terran/terrestrial/terrestrial/and, via French, terrene/tirin/, and from the Latin tellus comes tellurian/teilrin/ and telluric. Chronology. Formation. The bodies in the solar system formed and evolved with the Sun. In theory, a solar nebula partitions a volume out of a molecular cloud by gravitational collapse, which begins to spin and flatten into a circumstellar disk, and then the planets grow out of that disk with the Sun. A nebula contains gas, ice grains, and dust, including primordial nuclides. According to nebular theory, planetesimals formed by accretion, with the primordial Earth being estimated as likely taking anywhere from 70 to 100 million years to form. Estimates of the age of the Moon range from 4.5 Ga to significantly younger. A leading hypothesis is that it was formed by accretion from material loosed from Earth after a Mars-sized object with about 10% of Earth's mass, named Theia, collided with Earth. It hit Earth with a glancing blow and some of its mass merged with Earth, between approximately 4.1 and 3.8 Ga. Numerous asteroid impacts during the late heavy bombardment caused significant changes to the greater surface environment of the Moon and, by inference, to that of Earth. After formation, Earth's atmosphere and oceans were formed by volcanic activity and outgassing. Water vapor from these sources condensed into the oceans, augmented by water and ice from asteroids, protoplanets, and comets. Sufficient water to fill the oceans may have been on Earth since it formed. In this model, atmospheric greenhouse gases kept the oceans from freezing when the newly forming Sun had only 70% of its current luminosity. By 3.5 Ga, Earth's magnetic field was established, which helped prevent the atmosphere from being stripped away by the solar wind. As the molten outer layer of Earth cooled, it formed the first solid crust, which is thought to have been mafic in composition. The first continental crust, which was more felsic in composition, formed by the partial melting of this mafic crust. The presence of grains of the mineral zircon of Hadean age in Eorcean sedimentary rocks suggests that at least some felsic crust existed as early as 4.4 Ga, only 140 Ma after Earth's formation. There are two main models of how this initial small volume of continental crust evolved to reach its current abundance. 1. A relatively steady growth up to the present day, which is supported by the radiometric dating of continental crust globally, and 2. An initial rapid growth in the volume of continental crust during the Archean, forming the bulk of the continental crust that now exists, which is supported by isotopic evidence from hafnium in zircons and neodymium in sedimentary rocks. The two models and the data that support them can be reconciled by large-scale recycling of the continental crust, particularly during the early stages of Earth's history. New continental crust forms as a result of plate tectonics, a process ultimately driven by the continuous loss of heat from Earth's interior. Over the period of hundreds of millions of years, tectonic forces have caused areas of continental crust to group together to form supercontinents that have subsequently broken apart. At approximately 750 Ma, one of the earliest known supercontinents, Rodinia, began to break apart. The continents later recombined to form Pannotia at 600 to 540 Ma, then finally Pangaea, which also began to break apart at 180 Ma. The most recent pattern of ice ages began about 40 Ma and then intensified during the Pleistocene. About 3 Ma. High and middle latitude regions have since undergone repeated cycles of glaciation and thaw, repeating about every 21,000, 41,000 and 100,000 years. The last glacial period, colloquially called the last ice age, covered large parts of the continents, up to the middle latitudes, in ice and ended about 11,700 years ago.